I'm also going to post this as a video too in case anybody misses it. But today what I'm going to do, can everybody see my coffee mug and my model on the table?
Yep.
All right, so here's what I want you to think about. I want you to pretend that this model that you see on the table is like the mountain that was in the video on Friday. So if you remember back to that video on Friday, that mountain had a base at 2,500 feet of elevation, and we said the top was at 3,500 feet of elevation. So we got 1,000 feet of elevation from bottom to top. And then if you remember, I asked Mr. Byrne, how many spaces do you count in between the bottom and the top? And he looked at his map and he said 8. So what I wanted to try and show you was that on a map, can you see me kind of? Can you see me kind of? On a map, all we have to work with are 2 dimensions, but they're representations of 3-dimensional things in the real world. So here's what making topographic maps is like. If I take that bottom chunk of the mountain and slice it, then what I can do is I can take my marker and trace the shape that's left behind. And there's a little feature on the back side of this mountain that I'll show you. It's a little notch. But then when I remove that, there's our first contour line. Can everybody see that, kinda? I'll provide a better picture of it when we're all done. Then we would move on. We would go up another 125 feet. That was our interval. And we would place that and trace it. So real map makers obviously use more sophisticated technology, but it's based off this idea that we're taking slices out of a feature and tracing that onto a piece of paper until we start to get these contour lines. And I won't do that with all of these and take up all the time, but if I do that over and over and over again, with the feature that I showed you in the video on Friday, we end up with something like this. Can everybody see that? So that's a 2-dimensional version of this 3-dimensional thing here. And what I want you to be able to do on a topographic map is think about areas where, so this is that little notch. There's a little notch in this land feature here. So we could almost imagine water flowing down this. Usually anytime you see a notch or these V shapes on a topographic map, it's an indication that there's water there, like a little stream. The other thing I want you to be able to know about topographic maps is that anytime we have lines that are really close together, that would represent a steeper area of the map versus areas that are a little bit more spread out, That would be more gradual. So if we look at this model here, can you see, hold on, get that coffee out of the way. Like this area right here is kind of, let's see, this area right here. It's a little bit more gradual. I would want to hike up this because it's not as steep. If I compare that though to this right here, that's a lot steeper, and these lines would be really close together on a topographic map. So, just another way to try and get you to see how topographic maps are made, how we take a 3-dimensional feature of the land and put it onto a 2-dimensional piece of paper. So the assignment that I'm going to send you, it's going to post on Edmodo here in about 10 minutes. It's this picture here, and I've gotten you started with the number 2,500, and then at the top 3,500, and I just want you to tell me what these contour lines are if we follow our contour interval. And then I want you to complete the map with toads. Give it a good title, orientation, author, date, and symbols. So what questions do we have about